In part 1, we learned about the modulo, or mod, operator. The result of A mod B is what's left over when we remove B from A as many times as possible. Let's take a look at a couple of places where we could use this kind of ability in everyday life. Suppose that you run a car ferry. Every run of the ferry costs you money, so you want to fill up the ferry with cars as many times as possible. So you pull in the ferry, and the cars drive in, you fill it up, and you take off. When you're done loading up the whole ferry as many times as possible, a few cars will still be left in the parking lot, and you're going to have to give them refunds. So suppose that you've arrived at work this morning, and there's a parking lot full of cars. At the end of the day, how many cars will be left over that you weren't able to take, and therefore you have to give refunds to? Let's say that number of cars is the number of cars, and ferry capacity is the capacity of the ferry. Then number of cars mod ferry capacity is the number of cars that won't make it and you have to refund. For example, suppose that we have 1,807 cars and the ferry can take 144 cars at a time. Then we can compute 1,807 mod 144 and processing will give us back the value 79. There are 79 cars left over at the end of the day. Visually, we could draw a box that's 1,807 units wide and then lay in a single box that's 144 units. Now we just keep laying in repeated copies of that box, taking out 144 over and over and over until we're left with the little wedge at the far right, and that's 79 units wide. We get that result in just one go by using modulo. Here's another example. You have a bunch of blueberries and a class full of kids, and they want the blueberries. To be fair, you want to give the same number of blueberries to everyone. If there are any blueberries left over at the end, you're going to feed them to the class hamster. So the question is, how many berries does the hamster get? Of course, we're going to compute number of berries modulo number of kids. Let's walk through the process. First, we take our berries and we give one berry to every kid. The result is we have a smaller number of berries. So again, we give one berry to every kid. We have a smaller number left over. We give one berry to every kid. We still have enough to give to every kid. So every kid gets a berry, and now we don't have enough berries left over to give one to everybody. The remaining berries go to the hamster. This is number of berries mod number of kids. You might think that these are pretty unusual situations, and I would agree. But these kinds of things do come up from time to time, and when they do, modulo is a perfect tool. But that alone wouldn't have made modulo as popular as it is. The place where modulo really shines is when we use it with arrays. I actually did this when we drew our stack of circles. Here's that same program, and I use the same 8 colors over and over again. This is probably easiest to see if I make the pattern 8 steps long, and you can notice that I'm just recycling the same 8 colors over and over. But when the pattern is bigger or smaller than 8, it's not quite as obvious. Here's the code for that program. Now I don't want to go through it all because it's pretty straightforward, but instead I'll just point out how I used modulo with an array. Here up top, I've created an array of 8 colors. I call the array colors with a capital C because it's a global array. Now I'm going to scroll down to draw, and you can see that I have a loop that runs through each of the balls that I want to draw. So this integer I goes from 0 to some big number like 50. I use this to place the ball horizontally and also vertically. But I also use I to get one of the colors to fill with. Here's the key line. I call fill, and I hand it one of the elements of the array colors. Which element? I mod colors.length. So as I goes from 0 to 7, we get back array elements 0 through 7, the first 8 colors. When I is 8, this little expression gives us back 0. And from then on, the cycle repeats over and over. The index I can get as big as we want. and we will simply move through all the colors of the array over and over again. This is a very common thing to do when we write programs, and the modulo operator is the perfect way to accomplish this job. It's also great for simultaneously working with multiple arrays of different lengths, and that's the subject of its own video. Modulo may be a new kind of operation to you, but play with it a bit and you'll find yourself using it more and more frequently, particularly when you use arrays.